All right, pre-calcers, it's Unit 3, Lesson 2. Once again, I'm not reviewing the warm-up, so if you have questions about the warm-up, you need to ask your teacher. The answers are in the student folder, so have a look at those, and then if you still struggle with some of those answers that you saw, then make sure you ask one of the pre-calc teachers for some clarification. We're moving on to Lesson 2 here, so it's in this particular lesson today, we're trying to emphasize, or in this unit actually, last lesson you talked about simplification. So we gave you an expression and your job was to simplify it into the simplest form possible. I know that gets a little questionable. What does simple mean? So we try to say, try and write it as a single expression. Then eventually we're going to solve equations. So you know you're solving when you have an equal sign and we have the word solve. So that means you have to calculate the values of x, or what are the angles that when you take cosine of that angle, it would produce an answer of -1/2. So we would find those angles. And then today what our main focus is verifying identities. So when you're verifying, we do have an equal sign, but we have two different expressions that are set equal to each other. So we're not asking you to solve for x, we're asking you to prove, when you're verifying, prove that the left-hand side equals the right-hand side, or prove that the right-hand side equals the left-hand side. So if you look here, it says, what is the difference between a trig equation and a trig identity? A trig equation is true for only some of the values of x. So here we're actually asking you to solve for x. It's true, but it's only true for certain values. For a trig identity, it's going to be true for all values of x. We're not asking you to solve for x. We're just trying to ask you to prove, is the left-hand side equal to the right-hand side? So you would have to verify that by going through a process to show that that is in fact true. Your guidelines for verifying identities. Bulletproof number 1. You can only work on one side of the equation. Okay, one side of the equation. Don't attempt to do both sides because we will not give you full credit. Our advice to you is to start with the more complicated side. It just makes it easier to simplify a more complicated side than to take a simple side and make it more complicated. Okay, why do we only work with one side? Well, we only work with one side because we are attempting to verify that the identity is true, that it works. And so if you assume it's an equation and manipulate both sides and move one side to the other, then you're assuming that it's already true. But we don't know if it's true. We're trying to verify it. So we're only allowed to manipulate one side to make either the left-hand side look like the right-hand side or the right-hand side to look like the left-hand side. Okay, so how are we going to do that? Well, you need to look for different strategies. You might look for places where you could use your fundamental identities and substitute them in. Do you see reciprocals? Is cosecant in there? Put it in terms of sine and cosine, right? If you're not sure, you can put everything in terms of sine and cosine. If you see tangent, make it sine over cosine. If you see cosecant, make it 1 over sine. You might need to factor. You might need to get a common denominator of your fractions and add or subtract those fractions. You might need to multiply by the conjugate to get a common denominator, or just to make it simple. So use this list of hints or advice that we have for you as you go through, and I'll take you through as many identities as I can. So let's see. Example number 1. It says verify this identity. So obviously the left-hand side is way more complicated than the right-hand side, so I am going to manipulate the left-hand side. So I see I have secant squared x minus 1. Well, that immediately, when I see this x squared minus 1, I immediately think of my sine squared plus cosine squared equals 1. If I divide everything by sine squared, I would get 1 plus cotan squared equals cosecant squared. And if I divide everything by, if I divided everything by cosine squared, I would get tangent squared x plus 1 equals secant squared. Okay, so this is the trig identity that I'm going to use right here. if I move the 1 over, secant squared x minus 1, I can replace that numerator with tangent squared x. My denominator remains as secant squared x. Okay, so that's step number 1. I'm kind of stuck here. I don't see anything else to do, so what could I do? Well, I think I'm going to make everything in terms of sine and cosine. Some of you might replace this secant squared with tangent squared x plus 1. That's fine, but it's not really going to help. So instead, I'm going to replace everything with sines and cosines. So tangent squared is sine squared x over cosine squared x, and then secant squared is 1 over cosine squared x. So this is still equal to sine squared x. Now, because I have a fraction divided by another fraction, I can rewrite that, right? So I'm going to take this fraction here, and I'm going to multiply it by the reciprocal. So I'm going to multiply by cosine squared x over 1 with that first fraction, sine squared x over cosine squared x just stays the same. I take this fraction, flip it upside down, multiply. Awesome, because what happens? My cosine squareds cancel. So my last and final step is to say, look, my cosine squareds canceled, so I get sine squared x equal to sine squared x. So yes, in fact, that is true. The left-hand side equals the right-hand side. Great. Let's move on. Okay, verify. My left-hand side is one single trig function. The right-hand side, a fraction plus a fraction. Okay, so I'm definitely going to manipulate my right-hand side. So what should I do? Well, the only thing I can do is get a common denominator here. So for this first fraction, I'm going to multiply it by 1 plus cosine theta in the numerator and denominator. 1 plus cosine theta. For my second fraction, I'm going to multiply by 1 minus cosine theta, 1 minus cosine theta. And so when I rewrite it, my numerator is just 1 plus cosine theta plus 1 times 1 minus cosine theta, which is 1 minus cosine theta, and that's all over. Well, my common denominator is 1 plus cosine theta times 1 minus cosine theta. And if I multiply that out, that's the difference of squares. That just becomes 1 minus cosine squared theta. Awesome, so now I'm going to cancel positive cosine with negative cosine. So I get a 2 in my numerator. My denominator, what is 1 minus cosine squared theta? Well, remember sine squared x plus cosine squared x equals 1. So 1 minus cosine squared theta is just sine squared theta. Oops, it's theta instead of x. And what is, remember, 2 times 1 over sine squared theta? In other words, that's what that's saying. So what is 2 times 1 over sine squared theta? Well, oops, it's just 2 cosecant squared theta. 1 over sine squared theta is cosecant squared theta. So yes, you could rewrite that whole thing every time. And now we have the left-hand side equal to the right-hand side. And we're done. Great. All right, moving on to my example 3. Example 3, I'm going to obviously work on my left-hand side because my right-hand side is a single term. So I'm going to work on my left-hand side. What could I do? Well, I see this sine squared x minus 1, and I immediately think of sine squared x plus cosine squared x equals 1. So if I'm going to do sine squared x minus 1, what does that equal? Well, we have to move the cosine squared to the other side, so that becomes negative cosine squared x. So I'm going to replace this with negative cosine squared x. The first parentheses, I'm going to do 2 steps in one. The secant squared, I'm going to make that 1 over cosine squared x minus 1. Okay, so now what do I do? Well, I'm just going to distribute, right? 1 over cosine squared x times negative cosine squared x. Those are going to cancel. So I'm going to get -1. And then -1 times negative cosine squared x is plus cosine squared x. So going back over here to this, if we do cosine squared x, this is the same thing as cosine squared x minus 1, right? So what is cosine squared x minus 1? Well, it is negative sine squared x. So negative sine squared x equals negative sine squared x. That is true. You don't really need both of these steps. You could have gone straight from this step down to here. That's fine. This wasn't needed. But I'm trying to get you guys to see the connection with this Pythagorean identity. If we move the 1 over, it becomes -1. That means we have to move the sine squared over. It becomes negative sine squared. All right, moving along, example 4. I'm trying to do as many as I can in 15 minutes. Okay, example 4, I'm going to manipulate the left-hand side because it's the one with the plus or minus. It's easier to get rid of a plus or minus than it is to put one in. So I don't see anything to do other than to replace cosecant with sine. So on the left-hand side, I'm just going to do 1 over sine theta minus sine theta. Now, the only thing really to do is to get a common denominator. So I'm going to get 1 minus sine squared theta all over sine theta. Right? Because I have to multiply this by sine theta over sine theta to get a common denominator. So it's 1 minus sine squared theta over sine squared, or over sine theta. Then we can do what I call the butterfly. You can put sine of theta under the 1 and sine of theta under the sine squared. So it's 1 over sine theta minus sine squared theta over sine theta. So what is 1 over sine theta? It's I lied. This is not what you're supposed to do. I'm just going back right to the original. My bad. That wasn't good. So let me go back and fix that. Okay, we had 1 minus sine squared theta over sine theta. I was going right back to what I had before. Instead, what is 1 minus sine squared theta equal? It equals cosine squared theta. Phew, this is looking better. So now cosine squared theta, I can separate this into cosine times cosine. I can put that sine theta under one of the cosines and a 1 under the other one, right? 1 times sine is sine, so I've separated it. Well, cosine theta is just cosine theta, and cosine over sine is cotan. So here I have my cotan theta, my cosine theta. So that does indeed equal cosine theta, cotan theta. There you have it. Verified. Okay, I'll do one more example because it's going to have a conjugate strategy, and then you can check the other ones, try them on your own, and check the answers on the answer key. So here I'm going to manipulate the left or the right hand side. So anytime you see a fraction, if you see a plus or minus sign in the denominator, then start with that. So I'm going to start here on the left hand side of example 5, but on the right hand side in example 5, but in example 6 I would actually manipulate the left hand side. So what do? We're going to start by multiplying the numerator and denominator by the conjugate of the denominator to get the difference of squares. Okay, pause. Try to finish this on your own. I'm going to do the same thing. Pause, finish it on your own. Okay, so I multiply by the conjugate. I get sine times 1 plus cosine. This becomes 1 minus cosine squared. Then 1 minus cosine squared becomes sine squared, so I put that in there. Then I can cancel a sine with a sine squared, so it becomes 1 plus cosine over sine. Now we do our little rabbit ears or our butterfly, and we put 1 over sine plus cosine over sine. Well, 1 over sine is cosecant, and cosine over sine is cotangent. We've proved the left-hand side equals the right-hand side, so we are in fact done. Okay, try example 6 and example 7 on your own. Check the answers on the answer key in the student files, and see your teacher if you still need some help. Bye.